Well, welcome everyone, and thanks for joining us on for this webinar today. We're very fortunate to have Anthony Johnson, who is the Scalyr field CTO and has a huge amount of experience in the world of Elastic. And in recent developments and what's happening with the world of Elastic, it's a perfect time to really talk about some of the things that Anthony's noticed and how he's advising us as an organization to develop our own product in reducing a lot of the stress and overhead that normally is associated with running with an open source system. So Anthony will probably just share a little bit about his background, but to say that he understands the problems at hand is an understatement. So I'm going to hand over to Anthony quickly and allow him to introduce himself.
Awesome. Thank you, Neil. So the topic of the day is Elasticsearch keeping you up at night. This is a topic I'm very passionate about because coming from a background where Elasticsearch did keep me up at night and having talked with a lot of different companies, found out that a bunch of other people in a lot of different companies are also having the same challenges. So we'll first get the slide to go. First, talk about the agenda that we're going to do today. Basically, as Neil mentioned, I'm going to give some introductions, specifically about myself, who Scalyr is, and you joined in a webinar about Elasticsearch. So hopefully you know about Elasticsearch, but just in case, I'll give you a little bit of insights into that technology as well. I want to talk about some challenges with that technology, specifically the ones that I ran in with Elasticsearch. Talk about the solution that Scalyr can offer to make these challenges go away, and then give a bit of a conclusion on next steps and where to go from here. I will have a demo, so if you're this is not just going to be a bunch of slides. Will not be a live demo because we know how those go. So let's start off a little bit about me. Once upon a time, this engineer had a wicked beard and liked to have smug photos that kind of looked like Steve Jobs, and that was fun. And then the wife didn't like it, and I caught her on technicality. She said shave the beard, so I got rid of the beard and kept a mustache. And of course, she didn't like that too much, and so she persisted, and I got rid of the mustache. And pandemic me looked all pretty raggedy. And then if you look at the video today, that hair is now gone. So if you have any doubt as whether the pandemic is clearing up, I am back to a pre-COVID state. So I think we're going down a right trajectory. As for me, I am a human, and I say human specifically because I will make mistakes. You will probably find some mistake in here. I'd love to hear about those mistakes. But I personally love espresso. I love making espresso. I make sourdough with a natural sourdough yeast starter. And like a lot of people, I love board games, especially during the pandemic has allowed me to really get into a board game. I also love speaking. I've spoken at most of the really big cons, including reInvent and HashiConf and ElasticCon. I spoke at a couple times. I even spoke at Mindfair, which is a funny Mindfair is a Minecraft sort of con, if you would, where everybody gets together and has fun with Minecraft. And I thought, wouldn't it be neat to do something fun there? And so I basically generated an entire village in Minecraft built off a Twitter account, like with feeds and everything else. The fun thing about that is nobody saw it, wasn't recorded. So that was that. I also like to do hackathons. I won the AWS reInvent nonprofit hackathon twice, 2 years in a row. It was sort of a fun story as well. Hopefully you join me for other webinars where I can talk about that one. And as an engineer, hopefully this tells a lot about me. I know where my towel is. If you get the joke, awesome. If you don't, you should definitely need to read Hitchhiker's Guide to the Galaxy. So about 6 months ago, I joined a company named Scalyr. And this is a Scalyr webinar. So give some fair introductions. So Scalyr itself was founded in 2015 by a couple of Steves. Both of them came from Google. Steve Newman created Google Docs, and they were basically the project leads for sort of the productivity tools at Google. It was not a garage startup. It was started in Steve Newman's attic. And basically our mission, like most companies, has evolved over time, but our current mission basically is to deliver the best event data cloud for analytics, observability, and beyond. And what does that really mean? It means that event data that has a timestamp on it, we want to be the best and the experts at that data, managing the data, deriving answers from the data, storing the data. And really we achieve that with our what we call the golden ratio, which is basically we need to have a nice balance of cost, performance, and scalability, because data you can't afford or data you can't query is relatively pointless. So just a bit more before we jump in. Scalyr itself is a very modern platform, cloud native, supports what you'd expect for a data platform. We have integrations that we support. We tag into pipelines. We are able to take in metrics, trace, and logs. We have our own UI for, specifically baked for observability to begin with, but it's what you'd expect. We can monitor, we can do synthetics, we can suck in data from object store, and then ultimately being able to integrate downstream and make the best functional use of your data is one of our sort of key goals. And so, being able to query data that's super old, we have our hindsight. So, you can go and run queries over data that's 5 years old, or you can go in and integrate with Grafana, or this specific one, which is one of them, is integrate directly with Elasticsearch. So you can basically still visualize data in Elasticsearch and Kabana world, but actually be able to retreat, use that golden ratio that we strive for. So how do we deliver the golden ratio? How is Scalyr different? I think I wanted to call out a couple of the three. We achieved the golden ratio essentially through global optimizations. And what does that mean? That means that we are incentivized to make it cheaper and easier and for you to query the data. And the way we accomplish this is with being aggressively multi-tenant. And so if you think about an Elasticsearch cluster, every time you want to build a new one, you build a new one. And it's half of that infrastructure is probably sitting there not using 100% CPU. And so our goal is let's pull all these resources together. And whenever somebody runs a query against the data, it essentially is using all of the infrastructure to achieve that. And that allows us to as we grow, we get better with performance. So where others need to shard out and segregate infrastructure to be able to scale, we scale better with more. The next one is trying to find ways to avoid actually even querying the data. And so this is where being able to support materialized views comes into play. So we support the idea of summaries. You tell us, what data sort of view to maintain, and as events come in, we update that view. And what's even neater is we can go back in time. So if you had a year's retention of data, we can go back in time and rebuild a materialized view that you just came up with today, as an example. And then we coined this word horizontal scheduling. It really, a lot of this idea sort of came from Google. When in Google, when you run a search, it runs that search across all the infrastructure at the same time. Basically, you get the entire fleet to be able to execute that query at a time. And so instead of trying to parallelize thousands of queries at the exact same time, we end up handling each query one at a time, but we handle them super, super fast. And what that means for utilization is that our CPUs are basically 100% utilized majority of the time. And so it makes things a lot simpler. It also means that you get a lot more deterministic response as we get to respond to new usage data coming in. We can basically scale up dynamically since we're cloud native. And it's a really different way of thinking about it, where a lot of people are like, well, how many queries can I do at the exact same time? That's not really how we work. We say, well, how fast can we complete your query? And we have the infrastructure to be able to meet that. So a little bit about Elasticsearch technology. Again, you joined in a webinar about Elasticsearch, so I hope you were a little bit familiar. The Elk Stack, which is basically Elasticsearch, Logstash, and Kabana, they've also added the beats. I can't make that really work with the acronym, but the idea is that they have all of these sort of systems that they've built over time, all feeding data into sort of the central brain, which is Elasticsearch. Elasticsearch is a database based off of Lucene, and and it's running Kabana, not that hard. Running Logstash, not that hard. Running beats, trivial. Running Elasticsearch is really where all of the challenges come in. it's where all the grief is. It's what's going to keep you up at night. If anything in the stack is going to keep you up. And so it's really where I wanted to focus sort of how Scalyr can help and augment to make this better. And that's sort of where we, you know, where when I joined Scalyr, this was sort of one of my agenda items. I wanted to be able to, you know, take my pain points and lessons learned from the past and say, well, how can I make that story better for other engineers who find themselves in similar predicaments? And of course, we can't really go forward without addressing the elephant in the room around Elasticsearch. If you don't know, middle of January, Shay Bannon, the CEO of Elastico, he basically announced how they're doubling down on open by changing the Apache license to be more restrictive. And this caused a lot of fuss in the industry, you know, and of course, you know, a few days later they needed to announce another blog basically clarifying their intention and what it really meant. And they probably thought that was going to be the end of it. Nope, not. You know, they needed to now justify, because the community was like, what are you doing around this? And then, you know, even more clarification. So the problem is that, you know, if you want to use an open source library, the hope is that you're not having to bring lawyers and you're not having to weed through sort of legal jargon to see what your risk is. And of course, where this leaves the community is, you know, people are worried. People that have built their entire business on Elastic are a bit worried. You know, and you can start seeing this as sort of, you know, with forks in the community. Logs.io has talked about forking Elasticsearch. AWS Elasticsearch service is going to basically have a pure fork of it. And I think that really is the bad, you know, the sad fallout here is, you know, is basically death by 100 forks is what I coined. Yeah, there's not going to be 100. But the point is that as the communities fracture, as you start getting new, you know, new forks of data coming in, what ends up happening is, you know, you don't get parity mismatch. You know, you get different sets of documentation, you get different sets of expectations, and at the end of the day, the community's harmed by it. So for me, you know, when I originally started, this was probably 6 months to a year ago, I was really on the Elasticsearch side. I'm like, you know what, they deserve to not be sort of Sherlocked out of their invention by AWS. You know, but at the end of the day, telling the community and leveraging the community to build a product, and then sort of stripping that away when people have built their, you know, made business decisions based on it, it's a bit not all right. So I dive into this on a blog. You know, we want to give our opinion as well. And so we, you know, death by 100 forks. I do believe it'll be pasted in the chat. And we'll make sure that anywhere this goes, that you can, of course, discover it. If you want to kind of read my insights into where this is going and where I find this a bit of an issue, and honestly, what we should be doing about it. But now that the elephant in the room is out of the way, we'll talk a little bit about what I've learned about Elasticsearch. And specifically why I think it's essentially the wrong design. So, you know, to understand Elasticsearch, you really have to understand when it was created. So Elasticsearch was created well over a decade ago. And it was following sort of the patterns we had at the time. And one of the chief patterns was the idea of having a cluster that was quorum based, quorum meaning that you maintain data integrity by having a stateful cluster where data is alive, it's queryable. And this is really what Elasticsearch is founded on this. And so you build a cluster, you give it, you know, 5 nodes. You know, of course they need 3 to be able to form a quorum. And then you replicate data across those to make sure that across those 5 nodes, you always have data that's accessible. And the challenge with this is that it's hard to scale. As clusters grow up, you know, as they grow, they end up getting extremely chatty. They, you know, to maintain that stateful cluster, they have to pass messages back and forth. They have to be able to keep track of where data is at. So now they need a lookup table, and they honestly are just nonstop chatting. And so, you know, what works great as a 10 node cluster, you know, all of a sudden fails at 100 nodes or 200 nodes or 300 nodes. And it's not that you can't make it work. You can always increase your network speed. You can always add more CPUs. You can always isolate and start making things. It's just, where does the madness end? And sort of part of the problem also with data nodes is that usually there's a limit to how much data you can store per node. And so with Elasticsearch, I've found sort of the 3 to 4 terabytes is really starting to push the limit what it can address within its 32 gig recommended JVM heap size. And the challenge is 4 terabytes is just not that much data these days. Here at Scalyr, I mean, we're dealing with customers who are producing, multi terabytes a day. I mean, our platform can handle around 200 terabytes a day. To be able to handle that in Elasticsearch, just alone, you would need, hundreds of nodes to be able to support that daily ingest. So the point is what can we do that's different from those data nodes? And the reality is that with modern object store, our storage systems underneath have a lot of durability. They have a lot of checks and balances. And really that's at the heart of the Scalyr, is basically leveraging cloud storage to basically get around of this sort of scaling limitation around compute and storage being so intrinsically linked. The next one, I think, and I love Lucene. I think Lucene is a wonderful project for sort of enterprise search, and it works really, really good for companies to be able to derive, to derive answers from sort of data using keyword indexing. The challenge is that, using Lucene for something that is producing tens of terabytes a day and expecting that to come in and be indexed and then also be accessible in real time is a challenge. And, especially if you have multiple fields, if you have 200 fields, or in one of my data sets, we had 4,000 fields. And so as that data came in, having to sit there and analyze every one of those fields, update indexes at the same time while allowing people to go and query that data really was a constant conflict. So Scalyr doesn't use indexing. We actually organize the data efficiently on disk and then allow you to query it. And then of course we overlay those global optimizations on top of it. And the final one is a funny one for me because, schema on write. We'll do a little pun here about get it right or else. But at the end of the day, once upon a time, schema on read was the way to go. And, basically just dump the data in and we'll figure out how to make sense of the data later. And then everybody said, well, yeah, all that data itself ends up being hard to query. It's hard to normalize. It's hard to really just get a normalized view of the data. And so we basically said, we pivoted to say, oh, figure out all your schemas up top, which is really sort of, at the beginning, which is sort of an engineer response to the problem. Well, if we just spend all this time up front planning and organizing, then the problem goes away. The problem is that nobody has all that time to figure out all of their needs. Essentially, it's the anti-agile, suggestion, which is basically like, oh, go figure everything out, which is to say predict the future, which nobody's going to get the future right. So at the end of it, where we end up falling is somewhere in the middle, where we need something sort of that can do schema on read and schema on write and not penalize you for one or the other. And that's really where what the nice thing about our design is you can organize data up front, you can make it super queryable to get right. But at the end of it, if you get it wrong, that's okay too, because you can still derive answers from your data and still, graph that data and still make use of it. So we talked about the bit of the design challenges. I wanted to talk about the vicious cycle that I found myself in, that I find a lot of people that I've talked to have found themselves in, which is basically sort of a shampoo sort of metaphor on rinse, wash, and repeat. And so, like most people, somebody comes to you with a business need. They say, you know what, I have some sort of events, whether they're logs, whether they're security events, whether they're your aquarium outputting, data on what's happening at the moment. You sit here and you say, I'm going to start with an Elasticsearch cluster. So you start with an Elasticsearch cluster, and like a lot of companies, you probably build an ingest platform on top of it. And then you start plumbing in data into that. These could be coming from, cloud. These could be coming from Kubernetes. These could be coming from, a Kafka ingest. But the point is you start funneling data into that one. And of course, through that ingestion pipeline, data is being indexed into an Elasticsearch. And, you start out, you prototype something, it probably works. It works until it doesn't. And usually the first, notion of this is something bad happens in Elasticsearch. Maybe you ran out of space, or maybe you didn't run out of space. Maybe it's just too much data for too little compute. Because again, to be able to write data into the storage, you've got to go through a compute layer. And so to solve this, most people are going to add more Elasticsearch nodes, and the problem does indeed go away. It goes away until it doesn't, until it comes back, basically. And this gets into the pattern you get stuck into. And so, this pattern keeps going on where you're perpetually optimizing, you're perpetually finding out where the weak links in the system are. And so, you add more nodes again, and the problem does indeed go away. And so, we just get into this really vicious cycle of adding nodes, of optimizing. One easy way that I've heard many people solve this, including myself, is, you just reduce retention. One of my first Elasticsearch clusters, we started off saying, we're going to have 45 days of retention. And then, you get successful, as data comes in, all of a sudden you can't afford 45 days of retention, or you can't keep it stable for 45 days of retention, or you just run out of space and you don't have the time. So all of a sudden 45 days becomes 30 days. And I think on one of my systems, this was probably 4 or 5 years ago, I was down to 4 days of, 4 days. And it was a dark time when I'm sitting here where 4 days was still too much retention. And, and it was sort of like, do I need to go to 3 days? And so this is the reality that a lot of people are facing, whereas they have to make these choices. Do I add infrastructure and justify an ever increasing bill? Or do I reduce retention and justify it to my internal customers? What ends up happening is, Elasticsearch ends up in constant recovery. As you start adding in, hundreds of nodes, let's just say 50 nodes, you're going to have failures. You're almost guaranteed to have a failure, relatively often enough that you notice. And, and of course, to make these, since storage and computer link together, you want that storage to be as big as possible. So let's say, I've provisioned a disk as big as 4 terabytes to try to reduce cost. And the challenge is when that red node goes down, that cluster has to rebalance to really just keep everything stateful and in a good state. So, if you think about what's happening, as soon as you have to move data around, that's extra IO. That extra IO plus the write IO coming in, plus the read demand of your customers really just puts you into this a really, really tough math problem. And of course, as data is going along, hopefully we end up with data being inaccessible at some point. Basically we end up in a red status where we have to recover. And then, unfortunately, when these things happen matter. So you're either adding a lot of overhead of people to maintain this, or you as an engineer are suffering sleepless nights. And the more invested you are in the success of this cluster, the tougher it can be, and what ultimately happens is the business ends up lacking any sort of confidence in the answers they get from the system, because, with the instability comes, do I have all the data? Is the answer to the question correct? Or is it missing some, a huge amount of data? So this lack of confidence in queries running against the system because of this constant state of flux is really real. And I can't tell you how many times I've seen, walking into a place where Elasticsearch wasn't stable. It wasn't stable because of some sort of rinse, wash, repeat cycle with something failing. And so that was my experience. I know the experience has been met with a lot of other people. And for me, I sat here and I said, I personally lost the confidence. I personally wanted more sleep. And I was like, I need a new tool to be able to get myself out of this situation. And I looked in the market. I personally didn't find one. I found a couple that came close, but they were always having to make me make some sort of, trade-off that I wasn't comfortable with. And you have to understand, when you're in that situation, going to the business and saying, yeah, we made a mistake. I know we just spent 6 months to a year migrating everything to Elasticsearch or going with this Elasticsearch solution. Now we need to go and spend 6 months to a year pivoting off of it. It's really a conversation that is impossible to have without potentially putting your job in danger, or, I can't imagine having that conversation and it not being a torpedo for your career. So for me, I was in that situation where I was like, wow, as an engineer, I know I made a mistake. What is my solutions? And so when I came to Scalyr, I go, what I want is somewhere to put the data, because the grief of the system is not Elasticsearch. Like Elasticsearch, it's smaller scale. is not that hard to maintain. It's, you keep something smaller, coordinator nodes and master nodes, and relatively very small data nodes, and it works. It's easy to maintain. So for me, the problem was the data, and this sounds funny, but Elasticsearch really struggles as the data scales. And I don't blame Elasticsearch. I blame that it was a product created a decade ago, and our scales of data were just different. So for me, I'm like, I want to put the data somewhere else. And so in this case, I'll put the data into Scalyr, and I get to maintain my existing infrastructure. This is important because you have data contracts, custom applications, maybe a custom alerting system. Maybe you've built an entire product line on Elasticsearch events, and your customers are used to maybe even a custom Kabana interface. And you don't have time to rewrite that. You don't have time to spend a year and a half migrating people off of a custom solution. Or maybe you've just trained everybody on observability using Kabana with existing dashboards that you've invested in. And so where I was at was I needed to be able to maintain those data contracts. I can't just go and pivot the entire business because that's disruptive. So you get to maintain your existing infrastructure. And then basically there's a data bridge which is our Docker container, the Scalyr Elasticsearch connector, which basically will, using remote clustering. So you add the Scalyr connector as a remote cluster. And so Elasticsearch queries get routed to this connector. That connector then forwards those queries onto Scalyr. Scalyr services them with, parsing of that native Elasticsearch query. And so we have support for, pretty mature support for parsing Lucene, pretty mature support for supporting the Elasticsearch query language. We don't do document ranking. So if this is an enterprise search, you're probably not going to want this solution. But besides document ranking, we're pretty good parity for just about every feature that Elasticsearch supports. And so that query comes through, the query goes back. What's great about this is that if that query is both, if half the data is in Scalyr and half the data is still in Elasticsearch cluster, with the way Elasticsearch works with a sort of scatter gather, it will actually coalesce that into a consistent response. And so you can actually have data coming from both systems, both internal to Elasticsearch local and Scalyr, and you will have a single query coming back. So it really becomes an extremely non-disruptive solution, ultimately allowing you to reduce data nodes in the Elasticsearch cluster. And with the data nodes go away, most of your challenges of data migrations and all those, they end up being Scalyr's challenges. So that's sort of what the Elasticsearch connector does. How it breaks the cycle is pretty simple. So we're back in our rinse, wash, repeat cycle. We have, we have our ingestion. And so ideally what ends up happening is majority of the data now flows into Scalyr. So since you've built an ingestion pipeline, whether it's Kafka, whether it's Logstash or Fluentd, we have plugins to allow a nice simple fork. You enrich that data. Since we do not do indexing. So you create an attribute called index, or if you wanted your indexes to be indexed by customer name, you could tell us, you could actually configure it as customer. And then basically you have this bridge here where basically the connector bridges these two. And ultimately you get to maintain a much smaller cluster with a majority of the data challenges have been exported to Scalyr. And hopefully what ends up happening is, as writes are offloaded to Scalyr, you get that bridge. And then hopefully what happens is your sleepless nights are gone. And, with Scalyr, I mean, we're able to handle, 200 terabytes of data per customer per day. And that was before, that was where we stopped. As one of the Steves said, the system wasn't even breathing hard when we hit that. But ultimately, because this is what we do, we are globally optimized, and we are designed to be able to handle all of this multi terabytes of data ingest. Durability and confidence increase in your answers, and that's ultimately at the end of the day, that's where you get your win from. Is when the business can, running a huge Elasticsearch cluster, might stroke an ego somewhere, but at the end of the day, if nobody can ask questions of it and get answers, or if the answers you get are not dependable, then it kind of makes it a bit of a pointless exercise. And so our goal, of course, is We want durability and confidence both to increase. That's where we give you value. So I do want to give a demo. This demo is going to be Elasticsearch Kabana heavy because I want to basically show that being seamless. So we will show just sort of loading data in here just to kind of give an idea of pipelining. We'll use Logstash for that. We will analyze the data with a couple graphs. We will load the same data into Scalyr, and then we'll basically just show that you can analyze it in expected ways. And keep our demos nice and neat by recording them. You learn your lessons. So we start out with an empty Elasticsearch, and I believe in sort of holding me accountable. So basically we'll take a look at the indexes, and what you'll find is these indexes are exactly what you'd expect. I believe this is running 7.8, I think, maybe earlier support. We support anything from 6 all the way up to the latest version. If you need Elasticsearch 5, we can talk more. So to begin with, we'll actually take just a simple logs JSON. This actually comes from the Kabana sample data set for web logs. We'll read it in using Logstash, and we'll file it out to our Elasticsearch cluster that we're running. And I have basically, to accomplish this, I have just a very simple run that basically just runs a Logstash pipeline. So there's nothing fantastic here as far as running Logstash. The whole point was I wanted to be able to show you where the output was and where you would make your change to inject data going to Scalyr. So we come back to Kabana, we run, and just to keep us honest, here's the data. We have our rows there, and this all came from Logstash. So 5381 documents, and so what's this? This of course log would not be that big of a deal to maintain. It's really just an example of sort of how data would look. And so we'll do sort of, like I said, this is still setting up sort of an empty one, creating an index pattern, and then basically just showing that data indeed does exist. And this data, this data is old. So, here's the nice patterns of data coming in. So again, 5,000 events. It is data with attributes. We do supporting data in as sort of a raw message as well. And then we will just show sort of a typical Kabana use case of, let's show a graph of events over time. And then we'll also show my favorite visualization, which is a pie graph. And I think pie graphs are a great way of breaking down event-driven data over a time frame, because you're really wanting to look at how the dimensions break down. And I think it's for me, it's one of the big things that I think Kabana does well. If you've ever made a multi-bucket pie graph before, you will realize that that once you get past a certain number of sub buckets, for me it's about 4 or 5 buckets. Data really starts to sort of get a little hard to visualize with Elasticsearch and Kabana, because of our design, not using indexing and really sort of leveraging our materialized views and really just processing sort of a request of the data. I've been able to take us to 6 or 7 deep with, visualizing relatively well. So I was, pretty proud of that one. So at this point, we have created we've taken our empty Elasticsearch cluster, we have loaded data into it, and we've just set up a couple visualizations to say, here's how we want to look at some of the data. This last pie graph was basically just dividing up by host by URL. And so at this step, I don't want to be there. Yeah, here we go. So now at this step, we want to load data into Scalyr. So of course, this is a demo. I've already made a simple way to go there, but you'll notice here, that we change our output to be a Scalyr output, just a simple Logstash plugin. We have a field, called parser, which allows us to just parse data. And this parser will be nothing more than just parsing for JSON. So if you want, this literally could be parser JSON. And really that's going to be about it. We don't need to add an index attribute because there's already an index field in the JSON document. And that's what we're going to use to sort of create our virtual indexes. And so here's the Scalyr interface. So of course, Docker didn't start up that quick, but we cut out some of the dead weight. But basically, what we look at here is data appears very similar to what you saw in Kabana. And so this interface would be fine if you want to get rid of Kabana entirely. But the point is that you have those existing data contracts. That's where you still need rely on Kabana. So our UI can do everything Kabana does. The difference is that you need to maintain those data contracts. And so now we need to start the connector up. So index is the default. We specify it here just to be a little bit more upfront, but basically we have our index key, which tells us what attribute do we use for the index dimension. So every value in that index field will be visible as an index. And in this example, there's only one value in it, which is this Kabana sample logs. But for you, you may want to have 2 or 3 different ways to view indexes. So think about, you could have a customer view where each customer's data itself is segmented by customer. So now we're back here. So notice that's our existing data. We actually need to configure ourselves to be able to have this Scalyr Elasticsearch cluster configured. We use that remote clustering. So we basically called this cluster Scalyr. We could call it logs. We could call it, we could call it we could call it web logs if we wanted to, if you wanted to provision things very narrowly. And what ends up happening is with remote cluster search, everything that begins with a Scalyr : prefix will be routed to the Elasticsearch connector. And, and just like everything else, we need to set up an index pattern. If you had, 100 dashboards configured, we have a script to actually update index patterns as well, so that you basically can go update your existing index patterns your dashboards are built on. And then basically for us, it's all about parity. We don't want you to have to go change your dashboards. And so we try to, fields try to come through the exact same way. This was actually on a version before we had supported keyword, but we do support the standard keyword as well. So that if your dashboards are built on a field with a keyword on there, we can support that as well. And here we're just dealing with some Kabana interestingness with how it visualizes. So then we have our Kabana data source. This again is going to Scalyr. Requests are going to Scalyr and being visualized. And and then this is our previous pie graph. And then let's go see if we can actually visualize events from Scalyr. And so here, instead of selecting the built-in Kabana, we'll go with the Scalyr one. And then we'll do, essentially this is the same exact thing we did before. The only difference is now we're using Scalyr. And you'll see a little bit of the things like the scales being off or the resolution being a little bit thicker. We've worked on this. This was taken in December. We've worked on that since then, and those have been addressed. I think better resolution is awesome, but obviously we need to respect the request that's coming from Kabana as well. And so for pie graphs, same thing. We're basically just replicating what we did before, which is let's split the data for our time frame by host, and then let's split it again by our path. And this is really just wanting to show, or by URL. This is really just wanting to show that we can support the pie graphs, we can support the the max min, the average graphs. We support those bucketing types. And for majority of the use cases, we're going to work. Like I said, document ranking we don't do. Our platform just, our store doesn't do document ranking. So an enterprise search use case, probably not a good thing for it. But a generalized logging or observability or APM use case or security use case is definitely there. And we've actually been engaging with several security vendors built on Elasticsearch specifically for this use case, because they bet their future on Elasticsearch. They deal with the same struggling grief that everybody does trying to scale Elasticsearch, and it's expensive. And they say, how can we save money? How can we get more, how can we get more of our time back so that we just don't miss out on opportunity cost? And why are we doing that? There we go. We've already loaded data into Scalyr. There we go. So takeaways, and this is really where I joined Scalyr about 6 months ago. And it's really what I wanted to, this is really what I wanted to be able to do for engineers in the industry is, we are ready to help. I'm really proud of the connector. It basically started out as sort of a personal project from, by the field CTO. Engineering basically picked it up, engaged, and gave it all of the attention that a real, production level quality, solution needed. So Scalyr is ready to solve your ingest issues. We're ready to solve your scaling issues, and we're ready to solve your confidence issues. And what's great is that, while doing all that, we'll probably save a lot of time and money. And if you've already made it to here and these aren't any of your problems, I give you a kitten, and I hope that you will definitely look more into Scalyr for our, actual event data cloud UI UX solution that has parity with Kabana as well. So if you're looking for just Scalyr in general, we're there to solve these before these are even an issue for you. So next steps, our connector is in early access, and to learn more, Neil was our MC. That's Neil with 2 L's. He is the head of North American sort of sales. He can definitely help you out as well as just reach out to me directly. You can reach out to me on Twitter. I'm Ansonium. Look at my blogs. There's definitely ways to reach out and contact me. So Neil, I will hand it back over to you to close. I thank everybody for attending. Appreciate your time, and I look forward to working with all of you.
Thanks, Anthony. That was brilliant. I think, it addresses a lot of the things that were real to you then, but I think are even more real now for a lot of organizations. So I think that was hugely insightful. So thank you for that. Like Anthony said, you can reach out to either him or myself if you wanted to get any sort of further information or, further demonstrations. And we welcome the chance to even just get your ideas and your thoughts on the way that you see the industry is going today. So with that, thank you very much. And Anthony, thank you for a great webinar. And we look forward to speaking to everyone soon.
Awesome. Thank you, guys. Take care.